Welcome to Free GMAT Prep Hour, our first one of many. I hope everyone has seen the chat box and knows how to use it. I see Sanjay already typed something there. I will type something as well to say hello, everyone. And so students, please feel free to get on there and introduce yourselves. I will ask you for some participation in the chat box occasionally. And if there are any questions that you want to make sure that I see, then you can use the Q&A feature, which hopefully you see as an option somewhere on your screen. Since there are not a ton of students here, I'll probably be able to manage the chat box and see questions that come up there. But if you want to guarantee that I see it, use Q&A and I'll try to get to those questions and answer them if we have the time. So without further ado, I have planned some really interesting stuff to go over with you all today. Just wanted to show you the slide first in case you wanted to check out any of the other options and lessons that Manhattan Prep has to offer. So this is the link of where to go. And this is what we're going to be covering today. First off, we're going to look at a smart alternative to long division. I'll also explain the advantages of this alternative and why specifically for the GMAT, this might be a good idea. Then we're going to learn how to use that smart alternative specifically for the purpose of converting fractions into decimals, which isn't required a ton on the GMAT, but when it does come up, it's nice to know how to tackle that. I don't know how many of you have heard the term terminating decimals and non-terminating decimals, so feel free to let us know in the chat box whether you're familiar with that term. But today we're going to learn, I guess, why some but not all decimals terminate. And then finally, we're going to learn to determine whether a decimal will terminate or not. This is not the same thing as rational and irrational numbers. Somebody asked in the chat if it is. I believe rational numbers are numbers that can be presented as numerator and denominator. So for example, 1/3 would be considered a rational number because it's literally 1/3. So therefore it's rational. It's an integer divided by an integer. But this would be non-terminating. Most of you probably know that this would turn into an infinite string of 3s after the decimal point, so that would be a non-terminating decimal. On the other hand, 1/5, which I'm sure you all know is 0.2, that does terminate, right? So I guess this was a bit of a spoiler. Now we know what terminating decimal means and what non-terminating decimal means, but throughout this session, we're going to learn how to make that determination ahead of time, just by looking at the fraction. So if there are any questions along the way, the chat box is the place to throw those in. But if you have kind of global questions about other topics, then the Q&A would be the place for that. Okay, so let's talk about division. I prepared a few exercises here ahead of time, and I assume you all know how to solve these using long division, but I'd like to offer you an alternative. And what I'll ask you all to type in the chat box is perhaps a number that you can think of that is somewhere around 147, so kind of in that ballpark, that is very easy to divide by 3. You can just off the top of your head say, oh, I know what that is divided by 3. So go ahead and use the chat box to think of some numbers in that region, in that neighborhood, that you can very easily divide by 3. Nice. So I'm seeing a lot of 150s in the chat box. If I were to rewrite the question this way, 150/3, that would be a lie. It's not 150. It's 147. So I do need to fix it. I need to adjust so that we're not lying. Now what I wrote is exactly the same as the original question, and we can go ahead and divide each of these numbers separately into 3, and we get 50 minus 1 is 49. Let's try the next one. Some number somewhere in the kind of 200s area that is very, very easy to divide by 23. Okay, I'm seeing some of you like the number 230. That makes sense. It's very easy to divide 230 by 23. Again, though, I'll need to fix it. What must I subtract here to return to the original 207? That works out really nicely. And if you're thinking, well, Avi picked those numbers on purpose to make it look easy, I'll reveal that I actually pulled that out of an official GMAT question, where somewhere along the way you had to divide 207 by 23. And by the way, just as an aside, if you did try to use long division here, what you would do is you would ask, does 23 go into 2? No. Does 23 go into 20? No. Does 23 go into 207? Well, that was the question to begin with. So long division is completely useless in this case. And I think that that's why the GMAT chose the numbers that would make it useless. Whereas if you do this kind of thing, it's extremely easy. That will give you 10, and that will give you 1. So the answer is, whoops. So the answer is 10 minus 1 is 9. 665. Work with me here. What would you pick for 665 over 7? All right, I'm seeing some 700s there, so I'll have to subtract what? All right, I'll subtract 35. And so we have, effectively, we have 100 minus 5, which is 95. Okay. Someone by the name of Raul suggested 630 over there. So let's try that. So if I had done 630 over 7, I would need to add here 35. And so I would get 630 over 7 plus 35 over 7. I'm just showing this to show you that it doesn't matter how you go, you're always going to get the same answer. All right, so I prefer this by far to long division, partly because it forces me to think. It's not mindless. And if you thought that mindless is a good thing, well, in the GMAT, it's a very bad thing. The minute you go into autopilot mode, you're going to make mistakes in the GMAT. I want to show you why this is better than long division for other reasons. So I'm just going to make some space here. If this is the way that you do division, it makes it very clear that this turns into this. And so on the GMAT one day, when you'll have to simplify this expression, you're much more likely to think of doing this than you would be if all you ever do is long division. So I'd love to get some feedback in the chat box. Let me know if that makes sense to you or if you want to push back, etc. And then we'll look at the fractions at the bottom. Right on. Someone by the name of Prep wants to push back. So what's the pushback? You can't just say push back. You have to say, oh, I disagree, and here's why. Maybe you just didn't understand the question. All right, so in the meantime, I'm going to move on and look at these fractions at the bottom. This is a bit tricky because 11 doesn't go into 6. So what I'm going to do is I'm going to start a decimal like this. I have a 0 point something. And by doing that, I'm allowed to give the numerator, the 6, a factor of 10. So the exercise turns into this. Now, the only thing I have to do, now that I've given it a factor of 10, is I have to remember that the answer to this new question will go to the right of the decimal point. So by moving one step to the right, I'm allowed to, or I'm compensating for that by giving the question a factor of 10. And 11 does go into 60. Probably what I would do is this. So I would end up with 5 and another 5 over 11. Now what should I do with the 5 over 11? Can I get some suggestions? I love that, Vinayak. So Vinayak says, why don't we do the same trick again? We're going to turn that part into 50 over 11. So I give it a factor of 10 again. But the answer from that will go to the next place in the decimal. So the 5 that I got, this 5, that's going to live in the first spot after the decimal point. And whatever I get from the 50 over 11, that answer will go here to the second spot. And so 50 over 11, I'm going to do 45 plus 6 over 11, which is 4 and 6 over 11. So I'm going to go ahead and put the 4 right there. So I have 0.54, and now I still have a 6 over 11 to deal with. So I'm going to pause here and see if anyone has any reactions at this point in the chat box. To prep, you're absolutely right. It's exactly the same as traditional long division in terms of the outcome. I mean, it has to be. This is math, right? I can't let it give me a different outcome. The difference isn't in the result. The difference is in the approach and in the way that you think about it. And in long division, my argument is that you don't think about it. You just go on autopilot and go through the motions that you memorized. And in this particular case, the steps are the same. That's true. But in this case, and in this case, and in this case, we didn't do the same steps, right? We went over. We said 700 minus 35. So this approach that I'm suggesting is different in that it's much more flexible. Yes, in the current case, it's exactly the same. You win that point. Let me look at other points here. So Halsey is saying, wait, you're just going to keep getting 5, 4, 5, 4, 5, 4, 5, 4, 5, 4. Because look at what we ended up with. We ended up with 6 over 11, which is the thing that we started with. I have 6 over 11 here. Well, that was the question to begin with. So this is going to be an infinite loop. Now, I'm getting some pushback from two of you. Vinayak and Prep are both effectively saying, look, Avi, we're not buying it. Long division is just fine. In this case, maybe it's even faster. And so I want to be very clear that what I'm talking about here is not intended to make you faster. It's intended to make you more thoughtful. And it's intended to improve your understanding of algebra, which was the point that I showed earlier. So if you're on test day and you say, I just want to get this done as quickly as possible, I'm comfortable with long division, I want to do long division, I'm fine with that. I think that's a great idea. Because when you're on test day, your only job is to get as many answers as possible right and as quickly as possible. That's your job on test day. And that's all you should care about on test day. Up until test day, when you're studying, you have a very different job. Your job at home when you're studying is to become a more thoughtful person, to learn how to reason quantitatively. And there is no reasoning when you're just executing mindless operations that you memorized when you were 10 years old. So you're missing out on this opportunity to better understand divisibility when you're using long division at home. Further, I would say that once you've practiced what I'm suggesting here, long division will not be faster. It might be as fast, but it can't possibly be faster because this is exactly the same thing, as you said. Again, in some cases, this is the same thing as long division, as in this case. In other cases, it's better than long division. But long division would never be faster. It can only be as fast in some cases. If you've never done this before, I can see why it would seem like it takes longer. 7/50. I'm going to use the same trick, start a decimal, turn it into 70/50. Rewrite it as 50 plus 20/50, which is 50/50 plus 20/50, also known as 1 2/5. So I'm going to take that 1, put it here, and now I have to deal with the 2/5, and whatever I get from there will go here in the second space after the decimal. So I'm going to do the same trick. I'm going to give this 2 a factor of 10. So this turns into 20/5, which is 4. So there goes the 4. And ladies and gentlemen, we are done. It's 0.14. And the thing that I want you all to think about for a moment is, why does this decimal terminate, whereas this decimal does not terminate? So try to go back to where we started. We had 6/11, which ended up not terminating. We have 7/50. That one did end up terminating. I want you to think about why that is. Vinayak asked the question, can we do this trick indefinitely? Can we keep adding factors of 10 to the numerator as long as we keep moving to the right in the decimal? And the answer is yes, you can do this indefinitely. It never ends. Now, Vinayak is attempting to say, oh, maybe this is non-terminating because the denominator is a prime, but then he realized 2 is also a prime and that one would terminate. In this case, this is not a prime. Maybe that's why it does terminate. So it's an interesting theory. I'm not going to answer yet. We're going to discover it together in a little bit. Any other questions about this alternative approach to long division before I move on? Okay. This is a data sufficiency question. Let me know in the chat box if you're not familiar with data sufficiency. Maybe you're new to the GMAT. Just let me know. All right. Here are the answer choices for those of you who are new. So I'm going to give you a couple of minutes to think about this. So far, I have 3 different answers from 3 different people. Take maybe another minute, and then we'll discuss. Okay, so many of you picked A. And I'm curious why. Okay, so Halsey is saying, look, the only prime factors of 100 are 2 and 5. I can confirm that by drawing a prime factor tree. That would be 10 times 10, drop down to prime factors 2, 5, 2, 5. So that's true, Halsey. The only prime factors of 100 are 2s and 5s. And Halsey says, whereas 300 has a prime of 3, that's true as well. The primes of 300 would be 2 squared, 3 to the 1, 5 squared. I call that a prime box of 300. So that's true. So what? I'm just reading some comments here in the chat. So division by 100 is deterministic. You would just shift the numerator by 2 decimals to the right, whereas 300, dividing by 3 is okay. If not, you will end up with a recurring decimal. Louis, what cases did you test? I love testing cases. What did you test? All right, I'm seeing some great comments in the chat, but I think what many of you are failing to consider is that statement 1 allows for y to be 300. I don't know what y is. They're not saying y is 100. Y could be 300. And then what? Does that change anybody's answer? I mean, what if, speaking of testing cases, what if x is 100 and y is 300? 100 over 300, that's 1/3. That's 0.333 all the way to infinity. This is non-terminating. So statement one is actually not sufficient on its own. Now, before we move on, I want to show you all something pretty cool. It's exactly what Prep just typed in the chat box. I'm going to talk about that next, and then we'll come back to this question and finish it. What I'd like to do now is hide the question itself. So imagine that we read the question on the GMAT and it was too hard. It was too hard for us. We couldn't figure out what they're asking. But we look at the statements and they're pretty straightforward. Y is a multiple of 100, Y is a multiple of 300. I understand what that means. And these are my 5 answer choices. By the way, for those of you who are new to the GMAT, these are always the same 5 answer choices. That doesn't change in data sufficiency. And what Prep just said in the chat box is that statement 2 contains within it the information from statement 1. I'm going to explain what he means by that, or she. I don't know if Prep is male or female. But if we know that Y is a multiple of 300, then of course it's a multiple of 100. In other words, statement 2 implies statement 1. Or another way to say that is we can infer statement 1 from the information in statement 2. So I'm going to draw an arrow here from statement 2 to statement 1 to show, look, if I know statement 2 is true, then I don't need you to tell me statement 1. I can infer that on my own. And the reason that's such a big deal is because some of these answer choices don't make sense. I can eliminate some answer choices without even reading the question when one statement implies the other. Now, Prep says, Avi, you can go ahead and eliminate these. And so I want to talk about them one by one and see whether I agree or not. We'll start with A. Answer choice A says 2 things. Just focus on A. It says 2 things. The first thing it says is that statement 1 alone is sufficient. So just looking at that thing that I highlighted in blue, maybe that's true. I can't really say because I don't know what the question is asking. That part could be true. Now let's look at the other part, which I will highlight in pink. Statement 2 is not sufficient. Just the pink part on its own, I don't know. Maybe that's true. I don't know what the question is asking, so it could be true. But can they both be true simultaneously? If statement 1 doesn't give us anything on top of what statement 2 already said, and statement 2 wasn't sufficient, what chance does statement 1 have? Statement 1 doesn't have anything to add. We already knew all of statement 1 when we read statement 2. So if statement 2 wasn't sufficient on its own, there's no chance statement 1 would be sufficient on its own. You can also look at it in the opposite direction. If 1 alone is sufficient, and 2 gives us everything that 1 had, and then some, even more information than statement 1, then how would you explain that 1 is sufficient and 2 is not? If 1 is sufficient on its own, then 2 is certainly sufficient on its own. It gives us everything that 1 had to offer and more. Let me know in the chat box if that makes sense to you or if you need me to explain that one more time. Do you understand why we're eliminating answer choice A? Halcyon rule, yes means you get it, or yes means you'd like me to explain it again? You guys get it? Okay, perfect. Let's look at answer choice D. That was the other one that I think it was Prep who said we can eliminate. Let's see what D says. I'll hide E. So D says each statement alone is sufficient. Well, without knowing what the question is asking, maybe D is the right answer. I don't know. I mean, maybe statement 1 is sufficient on its own, and statement 2 is also sufficient on its own. Can we try to think of a question for which the answer would be D? Let's all try to think about a question for which the answer would be D, and type it in the chat box. I'm going to type something in the chat box here. Actually, that won't come up in the recording, so let me do it on the screen. What if the question asked, is y a multiple of 100? Then statement 1, of course, is sufficient. It tells us exactly what the question was asking. What about statement 2? Would that be sufficient as well? If you know that y is a multiple of 300, are you able to answer this question? Isn't every multiple of 300 also a multiple of 100? Oh, I think I got a bunch of great questions from Adam there. So Adam says, is y even? The answer would be D. That's a great one. He had, is y divisible by 10? The answer would be D. So I can't eliminate D without reading the question. Let's reveal all of the answer choices again and see if we can find another answer choice that can be eliminated other than A. So I agree we should eliminate A, but what else can we eliminate without even knowing what the question is, just by seeing that statement 2 implies statement 1? Emily, we just saw a few questions for which D would be the correct answer. Is y a multiple of 100? Is y a multiple of 10? Is y even? All of those questions would have led to D. So I can't eliminate D without knowing what the question is. Prep is now suggesting maybe we can eliminate C. And Halsey says that as well. Yeah, let's see what C says. So C says two things. It says this, but it also says this. Now, is it possible that both statements together are sufficient? Like just that first part, is that possible? Can't really say without knowing what the question is. It's possible that together they're sufficient. For example, if the question is y a multiple of 100? Both together are sufficient. Is it possible that neither statement alone is sufficient? Yeah, if the question asks something about X, neither statement alone would be sufficient. So blue on its own, I can't eliminate. Pink on its own, I can't eliminate. But is it possible for them to both be true simultaneously? Let's think about this. I like to think of answer choice C as the miracle answer choice because it kind of describes a miracle. It says, alone the statements are not sufficient. And if you take these two individually useless statements and combine them, boom, you get a miracle of sufficiency. And I'm just having a hard time seeing how that is possible when you have a statement that doesn't add any value on top of the other statement. If 2 isn't sufficient on its own, how is 1 going to help it? 1 doesn't have anything to offer 2. Does that make sense? Like statement 1 doesn't have anything to offer statement 2. So why would combining them be beneficial? What added value would statement 2 get from statement 1? Nothing. And Vinayak is asking, so wait, if one of the statements is a subset of the other, does that mean you can always eliminate C? And the answer is yes, you can always eliminate C whenever one statement is a subset of the other. So another example would be statement 1 says X is positive and statement 2 says X is greater than 5. Well, if I know it's greater than 5, of course it's positive. This is another situation in which statement 1 doesn't add any value. And so what you do in that case is you eliminate A and you eliminate C. I'm eliminating the answer choice that goes with the weaker statement, the subset. And I'm eliminating C, the miracle answer choice. Does that answer your question, Vinayak? Cool. So we can eliminate answer choices A and C in this question without even understanding what the question is asking. By testing cases, we showed that statement 1 is not sufficient on its own. Statement 2 is not sufficient on its own either because X could be 300, and Y could be 300, in which case the fraction would just be 1. And that is terminating. Or X could be 100, and Y would be 300. And that would lead to 1/3, which is non-terminating. So I proved, by testing cases, I proved insufficiency for each statement on its own. And we already know that C can't be the answer because statement 2 implies statement 1. So I'll pause here for questions, and then I'll show you a variation on this data sufficiency problem. Okay, I got a question asking whether I suggest that we review the statements before looking at the question during the real test. And my answer is no, I do not suggest that. So what I'm showing you here with the statements, with that relationship where we saw that one statement implies the other, that is a great strategy when you are not able to solve the question. In other words, it's a guessing strategy. If you're stuck, you read the question, it's way over your head. And by the way, we hope that about half the questions will be that way. I'm hoping that about half of the questions that I get on the test are way over my head because it's an adaptive test. So I want that to happen. And then when it does happen, then I'll look at the statements and see, okay, can I at least identify some relationship there where one statement applies the other, in which case I'll eliminate 2 answer choices and have a better chance of guessing. By the way, often the statements will imply one another. For example, X is greater than 3, and negative 5X is less than negative 15. Right, so if you divide both sides here by negative 3 and remember to flip that inequality sign, you end up with the same as statement 1. X is greater than 3. And so if statement 1 implies statement 2 and statement 2 implies statement 1, you can eliminate A, B, and C, all gone. And you have a 50-50 shot. So look out for that on the questions that are simply too hard for you. Now, Vinayak, I see what you typed in the chat box. Did I mean negative 5? I don't think so. Did I make a mistake somewhere? Yes, I did mean -5. Thank you. Dividing by -5 here. Thank you very much for that. Vinayak, I think you're making a classic error there. So let me show you the error that you're making. Vinayak is saying, hey, if I can eliminate A, which said this, right? If that's not true and I'm eliminating it, then based on that, I should also eliminate D. Because if this pink thing isn't true, then D doesn't stand a chance. Am I understanding you correctly, Vinayak? That's the reasoning? Yeah. Now, the mistake that you're making is that you're ignoring a very important part of answer choice A. Okay, so I'm just going to repeat this part because it's a bit confusing and I want to make sure that you all get it. We're not eliminating A because of the pink. We're not eliminating A because of the blue. We're eliminating A because of the combination of pink and blue. The pink on its own might be true, the blue on its own might be true, but they can't both be true at the same time when you have an arrow going from statement 2 to statement 1. So I cannot eliminate D. Okay, cool. Let's look at a variation on this data sufficiency question. At first glance, it'll seem identical, but there is a small difference, which hopefully you will notice. So hopefully you notice that the only difference between the questions is this information about greatest common factor. And I wonder if anyone can use the chat box to rephrase that part that I just highlighted in blue. What does that mean, that the greatest common factor of these positive integers is 1? I'm not familiar with the term coprime. I'm not sure that this means that they're prime. In fact, let me see if I can come up with a counter example. I would say that the greatest common factor of 8 and 15 is 1. Neither 8 nor 15 is prime. So it doesn't mean that they're prime. And I think I did see someone type in the chat box the right way to rephrase this, which is they don't have any common factors. That's it. Why do you think that might be relevant in the context of what the question is asking? And just as an aside, you always want to ask that. In every data sufficiency question that offers you free info, that's what I call that blue part. It's just free information, the questions then provided. Whenever you see data sufficiency do that, you have to stop and ask yourself, Why would that be interesting to know, given what they're asking? In this case, they're asking, is the ratio x over y or a terminating decimal? Why would that be relevant? What I mean, prep, is that it won't be useless, ever. There's always a reason why they gave us the free info, and our job is to figure out what that reason is. Otherwise, we're probably not going to do well on that question. Now, Adam says in the chat box that if they don't have any common factors, then x over y will always end up as a decimal. And so I don't even need statements. And the answer is D. So to Adam and to everyone else, that's never going to happen on the GMAT. There's no answer choice that says we don't need the statements. And I guess you could say, well, D fits. D is an answer choice if we don't need the statements. But that has never happened in the history of the test. You're always going to need at least one of the statements to answer the question. So if you get to the question mark and you think, oh, I can already answer that question without even looking at the statements, then you misunderstood the question. It's not a thing on the GMAT that you don't need the statements. Now, you're right, Adam, that this would definitely be a decimal, but will it be a terminating decimal? So I guess the emphasis is on the word terminating. Will it terminate or will it not terminate? That is the question. And that I don't know yet. Just because something is a decimal doesn't mean that it will or will not terminate. Now, normally, when you look at a numerator and a denominator, for example, if you had 8 over 10, what would you do to simplify that fraction? So I'm going to keep it in fraction form. I'm not talking about decimal. Keep it in fraction form, but simplify. How would you write that? Exactly. I think you guys are starting to see this now. Yeah, normally you would reduce if there's a common factor. And I guess I should have written it on the right side. You get 4/5, right? So if there's a common factor, the first thing you do is reduce. What the free info is telling us is that this is already fully reduced. Let me type that on the board. So what? So what if x over y is a fully reduced fraction? So what? That's true. Vinayak is saying, so with statement 1, x can't have any 2s or 5s in its prime box. X could be 17, for example. So let's say x is 17 and y is 100. Would that be terminating or non-terminating? Anybody know how to translate that into a decimal? Right, it would just be 0.17. That's actually really easy to translate into a decimal, and that's terminating. So that would be a yes, right? So that's a yes to the question. Can we get a no? One over 1100, that would give us a no. So that would work. Also, 1 over 300. That would give us a no. So statement 1 is not sufficient, which means we can eliminate A and D. And if you're familiar with this data sufficiency grid that we teach at Manhattan Prep, you can eliminate that first row. That's the beauty of the grid, is that you can eliminate an entire row right off the bat as soon as you've decided on one statement. Infinity. Oh, you're saying y could be infinity? It could be, but it would still have to be a multiple of 100, that infinity. And is it part of the test? Not really. Not really, no. Infinity doesn't really go into the GMAT. What about statement 2? Let's draw the prime box of 300 again. So the primes of 300 are 2 squared, 3 to the 1, 5 squared. And this blue highlighted info lets us know that X doesn't have any of these. And what that means is no matter what, you're still going to end up with this factor of 3 in the denominator. So now I think is the time to go back a couple of slides and look at those 2 examples that we had and talk about why one of them terminates and the other does not. So let's do that now. 6 over 11, we ended up with 0.5454 all the way to infinity. 7 over 50, we ended up with 0.14? Yeah, 14 over 100. And when you think about the methodology that we used, let's remember what we did. We kept giving the numerator a factor of 10, and another factor of 10, and another factor of 10. And we can keep going. I think one of you, maybe it was Vinayak, asked me, can you keep giving those factors of 10 forever, as long as you keep moving to the right in the decimal? Was that you, Vinayak? I think that was you who asked that. And I said, yes, you can. You can just keep giving the numerator more and more and more and more factors of 10. But what does that mean? When you give a numerator a factor of 10, what prime numbers are you giving that numerator? You keep giving them the same primes over and over again. Which primes are they? 2 and 5, that's right. So I have an unlimited supply of 2s and 5s that I can give the numerator to help the numerator divide evenly into the denominator, whatever that denominator is. Do you all see that there's no number of 2s and 5s in the universe that would help a numerator divide into 11? Because neither 2 nor 5 are factors of 11. The 11 is always going to be there. Giving the numerator factors of 2 and 5 won't help. Let me say it another way. Imagine that you're some positive integer and you're not divisible by 11. And your dream, the only thing you care about in the world is you want to be divisible by 11. That's all you want. And you're not, but you really want to be divisible by 11. And I meet you and you tell me your dream is to be divisible by 11. And then I say, well, you know, I have an unlimited supply of 2s and 5s. Please tell me how many 2s and 5s you need such that you will become a multiple of 11. So you're not already a multiple of 11, but I can give you, right, I can keep you multiplying you by 2s and another 2 and another 2 and 5 and 5 and 5 until eventually you'll be a multiple of 11, right? You'll achieve your dream. But that can never happen. Let's look at a numerical example because that was very abstract. Let's say that you're 30. 30 is not divisible by 11. What if I give you a factor of 2? Now you're 60. Still not divisible by 11. Now I'll give you a factor of 5. So you're 300. Still not divisible by 11. You're never going to be divisible by 11 because you'll never get a factor of 11. You have to get that factor in order to be divisible by 11. But there's no number of 2s and 5s that would give you a factor of 11. So I'm going to shut up now and see how you feel about that. Is that clear, or do you want me to explain that some more? Can you help me help you, Prep? Which part of it do you need further explanation with? Is it the fact that, so the conclusion was there's no, like, I can't turn you into a factor, I can't turn you into a multiple of 11 just by using 2s and 5s. Oh, why 2 and 5? Okay. When we use this method with a decimal, remember, I start the 0 point, right? That was the trick. And then I say, I'm going to put my answer here. And then I'm going to put my answer here, and then put my answer here. And why do we keep going to the right? Well, because I keep giving the numerator a factor of 10 and another factor of 10 and another factor of 10. That's the way decimals work because our whole number system is base 10. So the decimals are also base 10. In fact, it comes from the Greek tenth, I think. It's all tenths. And so all I can give you is factors of 10, but a 10 is just a 2 and a 5. So you're never going to become a multiple of 11 just from getting more factors of 2 and 5. On the other hand, the 50 here in the denominator, that I can get. Yeah, Adam, something like that, or maybe it's desus. You can Google it. I don't remember the exact term in Greek. But 50, if you look at the prime box of 50, that's 2 to the power of 1, 5 squared. Yeah, I can turn you into a multiple of 50 by giving you 2s and 5s. And that's why this one terminated, but this one did not. So if you're looking at a fraction that is fully reduced and the denominator only has 2s and 5s, you will definitely terminate. But if you throw in there any other prime other than 2 or 5, you will not terminate. And that is only if the fraction is fully reduced. And so when we go back to that data sufficiency question, knowing that the fraction is fully reduced, statement 2 tells us, hey, you have a factor other than 2 or 5 in the denominator. That will not terminate. In statement 1, I don't know if I have factors other than 2 and 5. I know I have 2s and 5s for sure. Maybe I have some other stuff. I mean, this is a multiple of 100. It's not equal to 100. Could have other stuff there. And if I do, it will not. But if that's all I have, or if I just have more 2s and 5s, whatever, then it will terminate. So that's why that's not sufficient. But this one is. I know for sure that it will not terminate. And the correct answer is B. Time for some takeaways. And this is also your last chance to ask some questions. So let's take a minute of quiet just to go over the takeaways. The correct answer to the first data sufficiency question was E. That's right. So you can clearly see here the connection between, okay, I'm giving the numerator factors of 10, and therefore it's just getting factors of 2 and 5. So any other prime is going to pose a problem. I'm never going to be able to get rid of any prime other than 2 or 5 in the denominator. Thank you all so very much for joining me tonight. I had a great time and I hope you did as well. And I hope to see you around at some point. And if I don't, good luck on your GMAT. Thanks for coming.